This is Angs here from EduGree. Today's session is on collections in Java. Collections is a group of data structures used for managing data in Java. So data structures are to a developer as what a chisel and hammer is to a sculptor. So collections framework is a large set of data structures used for managing data in Java. Collections is a group of individual objects represented as a single unit. Java provides collection framework which defines several classes and interfaces to represent a group of objects as a single unit. So managing data in Java, you need collections. To demonstrate the need of collections in Java, I'll show you a program. So looking at this particular program, if you look through, we have three different data structures which we have defined out here. One is an array, next one is a vector of integers, third one is a hash table of integer as key and string as values. Now if we look at how we add elements to a particular data structure, here we are looking at one of the initializations of an array. Similarly, to initialize this vector, we had to use this add element method out here, and then on the hash table we had a put method. When we get into this, if we are trying to access the values, if you look through, you need this square bracket operator access for an array. You needed a get method for a vector. In fact, even if you want to get the basic first level method which allowed you an access of an element in vector is get element. And the third one, which is for hash table, you have to use a get with the key value. And if you run this particular program, you can see all those values exactly as what we have expected. One here, and hello at the third system out print line thing. So as we saw it here, there was no specific structure or kind of a seamless continuation between different data structures for the access methods, either to fetch it or to update it, modify a particular data structure. So collections were required to give a kind of a structure to all these data structures. So we have now already dealt with the introduction part of this particular session. Now, as the major types of interfaces or classes or collections, what collections framework provides in Java are majorly, we can put them together in four different buckets, which are map, set, list, and queue and dequeue. So these are the four major categories in which we can define or describe the collections in Java. So in today's session, we will be basically talking more about the map interface provided by collections in Java, because map is one of the majorly and most widely used data structures in Java. So what is map? So map is a generic interface for a key value pair data structure. This map takes place of the dictionary class, which was purely abstract class and not an interface before collections framework was introduced. So what are the different types of map? So known sub interfaces, a lot of them. To quote a few: bindings, concurrent map, concurrent navigable map, logical message context, message context, navigable map, SOAP message context, sorted map. Uh, all known implementing classes of this map, a lot of them again. AbstractMap, again it builds on top of this particular map interface in itself. Attributes, AuthProvider, ConcurrentHashMap, ConcurrentSkipListMap, EnumMap, HashMap, the most popular one, Hashtable, identity hash map, linked hash map, printer state reason, properties, provider, rendering hints, simple bindings, tabular support, data support. These are a few along with tree map, UI defaults, weak hash maps. So notably, if we look at, there are a lot of implementations today, but the notable implementations for these hash maps, if we look through, they are widely accepted as uh, hash map, tree map, hash table, and concurrent hash maps. So we will look through what exactly is the difference between each of these particular data structures, and how does basically a hash map differs from a tree map or a hash table or a concurrent hash map. So what is a hash map? So a hash map is a hash table based implementation of a map. What does it mean is you have a hash table, and to avoid the hash table collisions, we have buckets. So it's a data structure where each key maps to a particular key in the hash table, and if there's a hash collision, in the sense there is a data already existing at that particular value, we add it to the bucket notified by that particular hash table key entry. So if we look into details of what hash map will look like, it will look like this particular table where we see there is a set of hash keys which are mapped against different set of buckets. So each of the key, when we specify, it maps to one of these hash keys, and this hash key has a pointer, or basically a location of the head node, and then it sequentially stores that value in a bucket. So if you are looking for a value in a particular hash map, it will first hash the key. So on the basis of the hash key, it will get to that particular node. It will get the head node of the list of the bucket, and then it will sequentially look into that particular mapping node for your particular lookup. So what HashMap does is basically it extends the abstract map and implements the map interface along with serializable and clonable, so that you should be able to serialize it and you should be able to clone it at any point of time. HashMap is unsynchronized and it is not thread safe. HashMap allows one null key and multiple null values. Also, HashMap, the important aspect of HashMap's performance, it depends on initial capacity, what we specify, and the load factor. So what is this initial capacity and this load factor? So initial capacity is the capacity specified while this particular map is being constructed, and this capacity is the number of buckets allowed in this particular instance of this map. What is load factor? So load factor is how full the map is allowed to build before its capacity is automatically increased. So basically, when to avoid a situation where a lot of hash collisions are happening and the bucket size is increasing. So as we understand, if we look at this particular diagram again, what happens is there's a bucket. So the hash key lookup is based on the key and the hash function, but the subsequent lookup is sequential in the linked list. So now consider a particular hash map which has a million records and each bucket carrying kind of 10k elements. So if you are looking up any particular key in a particular bucket, it will make 10k iterations in worst case. So it's it's of the complexity of n, right? So to avoid the same, what Java does is that when the total number of entries reach capacity into load factor, then the hash map is rehashed. So basically in that case what happens is the number of uh, hash entries are increased which is allowed in that particular hash map, and subsequently the buckets will increase. So this will reduce the bucket size and increase the number of hash key entries in this first part of the table. So in this way, the performance is so default load factor is 0.75. 0.75 load factor gives a balance between number of sparse entries which can be there, so and the performance. Also, HashMap is an unordered data structure. So what I mean by that is when you are adding elements to this particular data structure in a particular sequence, when you retrieve, you don't get back it in the same order. You may enter an element with key 1 and value hello, and another key with key as 2 and value as world, but when you are fetching the values, retrieving the values from the hash map, order is not guaranteed. So in the case, in the sense, if you are retrieving and while retrieval, you may get the second element first, in the sense the element with key 2 and value as world as first, while the key with value 1 and value hello as second in the sequence while retrieval. So hash map is unordered by design. Moving on from hash map, the next important implementation of a map is tree map. So what exactly is tree map? Is a tree map is a red black tree based navigable map implementation. So what does it gives is it maps the values and stores it as per natural ordering of its keys or on the basis of a comparator which you provide while constructing this map in a sorted way. So as this is a red black tree, it gives a performance guaranteed in log n for all the methods like contains key, get, put, and remove methods. So all these methods give the same performance of log n. This tree map basically extends AbstractMap and implements NavigableMap. So NavigableMap is the one which specifies or gives us a way to look through a particular map in a given range also. An abstract map as such, it gives the basic constructs for operating on the map. So along with, so now moving on from tree map, the next one is hash tables. So again, if you look back, hash tables are very similar in structure like hash maps. The basic difference, what is that is it extends a dictionary class. So it belongs to an era when collections framework was not there, and hash table used to map to abstract dictionary class. So it was not that structured. With 1.2, with JDK 1.2 collections framework coming in, it was reorganized and it started extending even AbstractMap. But before that, it used to only extend a dictionary class. So now, if we go by the nature of this particular hash table, it stores all non-null values as key or value. Does not allow any null key or null values. Hash table performance depends on initial capacity and load factors. These initial capacity and load factors are the same values as what we discussed during HashMap. I'll reiterate a little. Capacity is the total number of buckets allowed in that particular hash table, and the load factor is how full the hash table is allowed to build before its capacity is automatically increased or rehashed. So the default load factor again over here is 0.75, that is 0.75, and as discussed before, this is the optimal value which gives us the balance between performance and the space. Hash table is thread safe, it is synchronized, but there's a difference. It blocks your get and that is retrieval and modification. So there's a performance hit if we use hash table even for a synchronized application. So if you don't need synchronized data structure, you don't need, you should not use hash tables. In case you are using an application which is multi-threaded in nature and you have a data structure which is shared across, there's a map which is shared across, we should use a concurrent hash map rather than hash table. So what does concurrent hash map does, which is not there in hash map and which is not there in hash table? So concurrent hash map is a hash map which divides your hash map in different sections, and if a particular section is being data is being retrieved from a particular section on which there is no write being performed, no lock is taken. So each section has its own different locks. By default, there are 16 segments. Uh, this is again configurable if you need a more number of section, more number of parallelism. So you can increase the same value. So concurrent hash map is a hash table based hash map, which provides concurrency of retrievals and high concurrency for updates without blocking the entire table. So retrieval operations do not block. So they may overlap with the update operation, including put and remove. So retrieval reflects the current state of map at the time of operation being performed. And also concurrent hash maps iterators are intelligent. They are designed such that they work for one thread at a time. Table is dynamically expanded when there are too many collisions there. This is same again based on the load factors, based on the initial capacity stuff and all. The same thing is done. Now in case we need an ordering in this hash map, what do we do? So for that particular problem, we have another set of data structure, that's a linked hash map. How is it different from the regular hash maps? It's same, as it is a hash table based map, but in this case the buckets are different. The buckets are doubly linked list, and as well along with this doubly linked list they maintain the insertion order of each element, so that when you are retrieving the value you get back the values in the same order in which they were inserted in this particular data structure. So this helps in the case or in the use cases where we need an ordering in the retrieval of the values. So again, this has the same kind of properties just as a hash map has. Uh, it is again not thread safe, so you need some kind of an access control if you need a synchronization across threads for this ordered hash map, that is linked hash map. So you will need to have some locks around it, which will ensure that the data structure is synchronized if you need the same. But as it adds an overhead of maintaining the insertion sequence, insertion order, so in case if ordering is not required, linked hash maps are not recommended. So precisely I am coming to the end of this particular session. So to conclude on this, if we need a key value pair mapping, just a mapping, we have hash maps. If we need ordering in this retrieval and update, we should use linked hash maps. In case we need a sorted order or this elements in some kind of ordering according to our own use cases, we should utilize tree map. And in case we are using hash map across threads and we need concurrency across from performance perspective, we should use concurrent hash maps. Hopefully you would have got an insight into the different data structure implementations of map interfaces in Java. Hope to see you all soon on my subsequent tutorials on other data structures under collections framework itself. Till then, goodbye, good luck, happy learning.